in a section called Coroutines Basics. If you want to search for Coroutines Basics, and you will probably find the same page. Now, looking on the left, you can see there's lots and lots of subtopics all relating to coroutines. Coroutines is a rather large topic in Kotlin, and all these pages on Kotlin will be filled with lots of confusing sounding terminology that can be a bit intimidating to somebody brand new to the concept of coroutines. I don't want to spend too long here. I want to cover their introduction, hopefully try and put it in slightly more simple terms before diving straight in and having a play with creating a coroutine. So what does it say? A coroutine is an instance of a suspendable computation. That's a complicated way of saying a block of code where some of that code can hang or take a long time or pause before then resuming. So far in the course, we're used to the idea of a block of code running from top to bottom pretty much without delay. Things will be taking microseconds. There will be no discernible pause or delay when running the code we've written. But now we're able to write code where you can suspend, you can pause the execution and then resume after a certain amount of time. Suspendable computation. They talk about it being conceptually similar to a thread, in the sense that it's a block of code that works concurrently with the rest of the code, something running in the background. We've covered this in the concept on threading, asynchronous, concurrency, running at the same time as something else. But here's the key thing. A coroutine is not bound to any particular thread. It may suspend its execution in one thread and resume it in another. So what's happening is you have this block that represents the coroutine. It looks like a block of code, and the code we write can suspend, or it can take a long time. And we don't have to worry about anything to do with threads, or switching threads, or being performant, or blocking the code, preventing other code from running. The coroutine will do it all for us under the hood. So they're often described as lightweight threads. If you ever get asked for a one-liner in a job interview for what a coroutine is, you can say a coroutine is like a lightweight thread. If they ask you to go into more detail, you could say that when you run a coroutine, it will be constantly switching threads under the hood. It will be managing and scheduling what code should run where. It will execute things in the most appropriate thread. It can be used for asynchronous code, for concurrency, where you're running code in the background, running it alongside our main code. However, all of the thread management is taken care of in a very efficient way that doesn't block anything. So lightweight threads, superpowered threads, a fantastic solution to running asynchronous code, concurrent code, that is code that is running alongside other code in the background. Now, I'm not going to spend any more time on the documentation. To hopefully make this make a little bit more sense, we will dive straight into Android Studio and create a coroutine using something called a coroutine scope. And then we launch that to launch our coroutine, and then we can have a play with writing some asynchronous code, some code that delays or suspends before then continuing, and see how it doesn't block or freeze anything in our app or our UI. Very, very powerful. So that's a quick overview of the documentation. Let's not spend any more time here. Back to Android Studio. I've closed down all other files apart from main activity. On this occasion, introducing a Kotlin foundation, we won't be doing this in a Scratch file. It won't clearly show what's going on when we suspend our code and resume it. It kind of doesn't work properly. It does things all at once. We want to show how the code is suspending, is pausing its execution before then resuming in a totally smooth, non-blocking way. So if you can go to main activity and then in the onCreate function, we're going to write some code at the very end of the onCreate function to demonstrate our first ever coroutine. So how do you launch a coroutine? How do you run one? And the way you need to do that is to first of all give it a scope, coroutine scope. So let's type that with a capital C, coroutine scope. And this requires a context. Let's talk about the scope first before we talk about the context. So the scope is just some information for the system that runs this coroutine for how long the coroutine should live, where it should be run. And when we talk about the context in just a moment, if there's any particular thread or threads it should run on. So a coroutine scope is like the manager for our coroutine. It will handle where to run the code. It will free up resources when we pause it and then resume it so it doesn't block anything. So if the coroutine is the way that we can run some suspending code, the coroutine scope is the manager for that. So a coroutine scope needs a context, and this can often be used to specify which thread to run it on. Well, to show this in action, I want to actually update the UI. I want to update something in our app. And so we should run this on the main thread. And you do that with a complicating sounding thing called a dispatcher. But a dispatcher is just the Kotlin coroutine way of saying where to dispatch, where to execute that code. And that can be used to specify the thread. So inside this coroutine scope constructor, we will do with a capital D, dispatchers.main. So this is saying, create me a new coroutine manager, a coroutine scope, where these coroutines will be executed, and please execute any of the actual code on the main thread. And the coroutine and this coroutine scope is going to take care of switching to the thread when ready, pausing and taking things off the thread to free things up. It's all very clever under the hood how it does it. It does it automatically. So now we have this scope, and we've told it which thread to run on, the main thread. We can then do .launch, and then now this block is the coroutine. This is where we can run code that can suspend, long-running code, code that might hang or delay. So let's do exactly that. Let's actually do a delay. Because we're in a coroutine scope, we have access to a delay function as part of the Kotlin X coroutines library you can see there. You can't do this outside of a coroutine. You can try, but you'll get an error saying this can only be called from a coroutine or another suspend function. And we'll get onto suspend functions in the next tutorial. But we can't run this outside of a coroutine or suspend function, but we can run it inside a coroutine. So this can take a duration in milliseconds. So let's do 3 seconds, 3000 milliseconds. And so let's do something after 3 seconds. Let's do a simple toast. Toast.makeText. The context can be this activity. We'll say hello from our very first coroutine, exclamation mark. We'll do length long, and then we'll do show. So what do we expect to happen? Well, we're hoping that this 3-second delay won't block our app. So we're hoping that when we run this, the app will start as normal. We're even hoping that we can click around and maybe open the bottom dialog, that nothing is blocked, nothing is frozen. And then, after 3 seconds, we want to see a toast. And we want to see it without an error or a crash because we're doing some thready stuff, we are delaying things, and we're doing it on the main thread. So we want to confirm, can we do some long-running code, a 3-second task like this, and still update the UI? So let's go ahead and run this and see what happens now we've launched our very first coroutine. 1, 2, 3, and there's our toast. No error, no crash. Even though this happened in the onCreate function of main activity, we saw all of the UI. I'm going to go ahead and run this again, but this time I'm going to try and open the bottom dialog. So I give myself a bit longer. I give myself 5 seconds. And I'll run this again, and I'll make sure that I can move the app, that I can click things, that nothing is frozen. So let's do this again. I'm in, so 5 seconds. I can open the dialog, I can close it, and then after 5 seconds, we still get the toast. Fantastic. So let's break down what's been happening here. We define a coroutine scope, a new object that says, hey, I will be the manager of this coroutine, and we give it some context. Like, okay, you're going to run some asynchronous code, some background code. This code might take a long time. Where actually do you want me to execute it, on which thread? And we're saying, well, we have some user interface stuff that has to be done from the main thread. So please, when you do get around to executing this, do it on the main thread. And under the hood, this coroutine is handling all of the things that take a long time. This 5-second delay, well, it's pausing the execution. It's not freezing anything. It's just stopping the execution, scheduling something to run 5 seconds later, and then eventually, after 5 seconds, it continues. And it does something that we can normally only do on the main thread, which is some UI stuff. So this is the power of a coroutine. You can suspend execution. You can pause things. You can run long-running operations. And the coroutine and the coroutine scope will manage it under the hood. And we can actually write our code as if it is blocking, as if it is synchronous. One line after the next line. And rather than things running straight through, well, these lines suspend. They pause. No need for callbacks, like we have in our tasks view model, if I quickly jump into that. No need for this kind of thing, opening a thread, doing the operation, and then giving it to some callback function, which makes for some very dodgy looking code. You see that there, fetch tasks, callback, run on the UI thread, callback. None of that. You can write your code sequentially, one line after the next line. It doesn't matter if the line takes a long time. So we get to run asynchronous code, code that can run in the background, code that can run on different threads. We don't have to worry about thread management. The coroutine will take care of that. And whenever we have some code that needs to pause or takes a long time, it will handle the scheduling, the pausing, and then the resumption of that. And so we're able to write code like this, which pauses for 5 seconds and still updates the UI. And it's incredibly powerful. However, at this point, the concept might still be a bit lost on you. It looks a little bit like a thread, right? If I compare this launch thing with our view model, it's just another lambda. What's the difference? And the real power of these coroutines, this block which we can run with suspending code, is actually in writing functions that suspend, extracting some of this code. So rather than doing it all inside this little block, we can actually write a function that might take a long time, that might access the database, or it might access a web API and download something. We can write long-running functions that suspend, and those functions are called suspend functions. So in the next tutorial, we'll jump straight into the concept of suspend functions, and then immediately see how they link to coroutines. And the ultimate goal will be to understand how it can totally transform the kind of code that we can write. Normal looking code, one line after the other, no callbacks, no thread switching, just a simple code. In the last tutorial, we had an introduction to coroutines. We learned how a coroutine is like a lightweight thread in which we can run asynchronous code, code that runs in the background on different threads, but write it in a normal synchronous way like this, along with its efficient way. And you can imagine this code function. Let's remove this code. And let's say we wanted to do something where we do something every second. Maybe we can change the title of our app every second just to show this working. But we don't want to do it right here in onCreate. We want to launch our coroutine here, but we want to move the code somewhere else, like in normal function, to keep our code tidy. For now, we'll do it just here in the main activity, but perhaps we'd want to do that actually in a view model. So the way you would do that is by writing a normal function. So we'll do a function called start title ticker. We'll update the title of our app every second just to show this working. So that's a normal function, but instead, before the word fun, we put the word suspend. Now, right now, this word suspend is grayed out because we're not doing anything that needs to suspend. Android Studio is saying, hey, this is just a normal function. You don't need to say it suspend. Nothing is being suspended. But if we call the delay function, well, now the suspend operator becomes highlighted because this is suspending. This will pause every second. And without that, you're simply not allowed to call this delay function. Okay? So this is now a suspend function. So we could do a loop like while true. So go round and round and round forever. This is an infinite loop. And then we'll delay for a second. And then we will access our binding, access the toolbar, get the title, and we'll change that every second. So to do that, let's make a variable outside of here called the count, initializing it to 0. Actually, let's initialize it to 1. And then every second, we will just update the title to be this timer. We'll say seconds, and then the count. And then at the end of the loop, we will do count plus plus to increment that. So now this is a suspending function. This 1 second delay happening over and over again, well, written normally, that could pause the code, that could freeze our app, but not in coroutine world. So we write a normal function, mark it with the word suspend. We're not allowed to call a suspend function outside of a coroutine. We can't start the title ticker there. That won't compile. That won't work. But what we can do is we can run it inside a coroutine like this. That is perfectly fine. And this is quite neat and tidy code. We start a new coroutine scope, a coroutine manager, specifying we want it to execute on the main thread because we want to update the UI here. And then we launch it, which kicks off our brand new coroutine, this block here. And inside this block, we can write blocking code that takes a long time, code that we want to run asynchronously in the background. And so we call another function, a suspend function. And this function here reads just fine, no callbacks. So let's go ahead and run the app now and see what happens. Seconds 1, 2, 3. We have a sort of clock in our app. And you might think with this infinite loop happening, with this 1 second delay, it could impact the performance of our app. But if I click on things, the app works just fine. The dialog works. I can add new tasks. Still, you see the clock ticking in the background. It's working as expected. And that's the true power of coroutines. Coroutines, working with suspend functions, can write high-performing code that doesn't block anything, code where all the thread management happens automatically. That's why they're thought of as lightweight threads, because rather than manually having to create a thread each time, it's doing it all under the hood, scheduling things, pausing things, and it just allows us to write neat and tidy code. So we'll delete all of this code now out of main activity, now that we've learned about coroutines and we've seen a suspend function and how they work together. So let's remove all that for now. And in the next tutorial, we'll look at applying this to the real need that we have in our app. I'm back in tasks fragment, where we've improved things by using a view model. However, especially with our fetch tasks function, things are still a bit messy. We're still having to manually talk about threads and switching threads and whatnot. We can now use coroutines and suspend functions to make things a lot better. I'm going to go ahead and command click into update task to get to our tasks view model. And I'm also going to command click on one of these task DAO functions. So I'll command click on update task, control click to get into our task DAO. So the really good news is that the Room library, Jetpack Room, is already built for coroutines and suspend functions. All we need to do for Room to automatically run these things on a background thread to make them suspend functions is to simply put the word suspend in front of them. So we can do suspend fun for create task. And we can copy this, put it in front of all of these functions. So we're now saying that all of these functions, they can suspend, they can pause, they can take some time. And so we will now have to run them from a coroutine. It's going to cause some errors in our view models, and that's okay because we're going to fix it. So if you can do the same, go to your task DAO and put the suspend operator in front of each of those functions. So now we can go back to the tasks view model and we have some updates, and it says we must call this from a coroutine or another suspend function. So let's do exactly that. So you might think I'll go and do coroutine scope and dispatches.main and then do .launch, and that's one way to give ourselves a coroutine. However, this code just here isn't specifically doing anything to do with the UI. So we could actually do .io, which is another thread, a thread that is commonly used for input and output operations, like databases, like networking. So you'd think, okay, we can do coroutine scope.dispatches.io, give me a coroutine scope that will manage the coroutine and run it on the IO thread. However, there's a better solution in view models and in views like fragments and activities. We can create a ready-made scope called view model scope. This is a pre-made, pre-configured scope that will live for as long as our view model lives. We already talked a few tutorials ago about how view models are linked to the life cycle of fragments and activities, that they live throughout the whole life cycle. Well then, if we then use that in conjunction with view model scope, this will be a coroutine scope that will live for as long as the view model, which is exactly what we want. So we can actually remove this coroutine scope dispatches.io and use a pre-configured scope that is perfect for view models called view model scope. So view model scope.launch. And then we can do this code here. So we can remove the thread now. And we'll do the same thing here. Update task. We will launch a new view model scope. And we'll update the task there. I'll copy all of that, paste, and just change that for our delete task. So now we can remove all of our threads. We are using coroutines. Not only that, but we're using a scope that is tailor-made for view models called View Model Scope. And this all comes out of the box with new versions of Android Studio with new projects. No new dependencies needed. You get this for free. Now, we're still using this callback that I don't quite like, but that's okay for now. And we also have some code in main activity, main view model for creating tasks. So let's go to our main view model. We need to replace this thread. Again, we can use View Model Scope and launch that coroutine there. And we can put our suspend function inside there and delete the thread. Let's go ahead now and run this and see how far we get. Everything still works as normal. I click plus, I can add a new task and click save, and everything just works. We've removed our need to use threads. Our code in the task fragment is more tidy. We call a view model. When we command click on this, we launch a coroutine scope, and we just call the task now. No need to create a new thread. This coroutine will be high performing. It will do all of the switching and suspending under the hood. And our task now uses suspend functions. By putting the suspend word at the start of the function, we're telling the room library to use coroutines. And when this compiles and makes the real code that we saw when we first made our DAO, it will do all of the code under the hood so that creating, fetching, updating, and deleting our tasks will happen using the correct dispatcher, the IO dispatcher to be precise. It will do that for us, so we can just use View Model Scope. There's one final thing that I want to do to improve our code. We're still using this callback function. I don't want to do that, so I'll get rid of this. No more callback. However, how can we return the tasks to the fragment? After all, we can't do return tasks. We can't make this a return type of list of tasks because we are still inside this coroutine. That just won't work. So what could the answer be? Well, the update task and the delete task, and indeed the create task functions, we don't really need any UI update. That can just happen. So we can launch View Model Scope, launch a coroutine, fire that off, and then forget about it. But for fetching the tasks, we do want to know about it. We want to get the tasks and then receive them. So rather than launching a coroutine here, let's remove this. I'll remove that. Let's remove that altogether and turn this function into a suspend function. And so now we can simply return the tasks. Just auto format that. Remove the line breaks. So look how normal this function looks. Apart from the word suspend, it behaves just like a normal function. We write code, one line after the other, no need for callbacks. This getAllTasks function, it's a suspend function in our DAO, you can see there. So it might take a moment or two, it might hang or freeze, but we're saying to Kotlin, this function is a suspend function. This might suspend for a moment or two. So then, when we call this from the fragment, all we need to do is launch a new coroutine scope and call this function, and then we will get our tasks. If I go to the task fragment, well, we now have an error here, not only because we're not using the callback, but also because this is a suspend function, which must run from a coroutine. So we can launch another scope. We could do coroutine scope dispatchers.main, we could manually say that, but just like view model scope for view models, there is a ready-made scope for fragments and activities that plays very, very nicely with the life cycle of a fragment and an activity. That is to say that it will start and stop whenever the fragment or activity comes alive. It's very efficient. It means you don't run the code when the app isn't running or in the foreground. And that scope, similar to our view model scope, is called lifecycle scope. It's a pre-configured scope that will run on the main thread, so we're allowed to update our UI from it. And if I launch this, I can simply call viewModel.fetchTasks, and this will return a list of tasks, just like normal code. And then once we've got the tasks, I can set tasks, just like that. So now we can go ahead and delete all of the thread code, all of the callback code, and when we run this, everything works as normal. I can add a new task, my very latest task, click save, and I see it. So coroutines are absolutely fantastic. They allow us to run code that runs in the background or asynchronous code, but when writing it, it looks just like normal code. We can write suspend functions that look just like normal functions to run code that runs latest task, click save, and I see it. So coroutines are absolutely fantastic. They allow us to run code that runs in the background or asynchronous code, but when writing it, it looks just like normal code. We can write suspend functions that look just like normal functions. And so moving forwards now, no more manual thread creation. We will use all of the power of Kotlin by using their coroutines and suspend functions. And from this point of the course, all asynchronous code is going to be a lot easier to work with. Okay, now that we're armed with coroutines and suspend functions, let's continue.